In 1860, an American machinist could cut a flawless part and still be useless to the factory across the street. A bolt threaded in one shop would not reliably fit a nut threaded in another. A gear sized by one tool room would not always mesh with a gear sized by the next. Every workshop in the country carried its own private idea of how long an inch was, scratched onto its own steel rule and kept in the head of its own foreman. There was no national inch. There was no agreed standard of length anywhere in American manufacturing, and without one, the central promise of the machine age was only half true. You could make 1,000 parts that looked identical. Whether any one of them would actually drop into any machine and work was a separate question, and most of the time the honest answer was no. This was the wall that two machinists hit in a Hartford gun shop, and it was the wall they spent the rest of their working lives tearing down. Their names were Francis Pratt and Amos Whitney. Almost everyone has heard the name they share. Almost nobody knows it started with them. The Pratt and Whitney you see stamped on jet engines today, the company that powers airliners and fighter aircraft, borrowed that name from these two men decades after they had already changed the way nearly everything in America got built. The engines came much later. The standard came first. Pratt was born in 1827 and grew up around Lowell, Massachusetts, where he was put to work as a machinist's apprentice while he was still a boy. Whitney was born in Biddeford, Maine, in 1832, and by the age of 14 he was already apprenticed at a machine company in Lawrence, Massachusetts. Two New England boys, both raised on metal, both clever with their hands, both pulled toward the same city for the same reason. Hartford, Connecticut in the 1850s was one of the great centers of American precision work, and the engine at the heart of it was Samuel Colt's Armory. Pratt arrived in Hartford in 1852 to take a job at Colt. Whitney arrived the same year for the same kind of work. They met on the floor of the Armory, two young men machining parts for revolvers. Colt's works in that era was the closest thing America had to a university for precision manufacturing, and a striking number of the men who would later build the nation's machine tool industry came up through it. Within about 2 years, both Pratt and Whitney had moved on to the Phoenix Iron Works, operated by George S. Lincoln and Company. Pratt eventually became superintendent there. While he was at Phoenix, he designed a milling machine for the Lincoln firm that the whole trade came to call the Lincoln Miller, and more than 150,000 machines would eventually be built on that basic pattern by shops across the country. Before the two men had a company of their own, Pratt had already drawn one of the most copied machine tools of the century. They made an unlikely match that somehow held. Pratt was the designer, the one obsessed with accuracy and the exact geometry of a cut. Whitney was the builder and the organizer, tireless, the man who ran the floor and watched the money. The arrangement lasted close to half a century without cracking, which was rare then and is rare now. Every week on this channel, we tell the stories behind the machines and the people who built the modern world. If that is the sort of story you came here for, take a second to give this video a like and subscribe so the next one finds you. It honestly makes a difference to a channel like this one. In 1860, while both were still drawing wages from the Lincoln Works, Pratt and Whitney opened a small shop of their own on the side. They did not quit their day jobs. They could not afford to. They rented a little space, took in small contract jobs in the evenings and on weekends, and grew the new business one order at a time. It was a cautious, almost nervous beginning for a firm that would end up writing the rules for an entire industry. Then the country went to war. When the Civil War broke out in 1861, the Union needed rifles faster than any factory could produce them, and it needed them by the hundreds of thousands. Over the course of the war, the North would manufacture something on the order of 1.5 million rifles, along with mountains of other arms. But a government cannot simply order that many weapons into existence. It needs the machinery that makes the weapons, the boring machines and rifling machines, the lathes, the milling machines, and the gauges that let a factory turn out one identical rifle after another. This was the work Pratt and Whitney understood as well as anyone alive. They began producing guns, and far more importantly, the machines and tools to produce guns, and they sold that equipment to the armories arming the Union. The distinction matters. Pratt and Whitney's lasting business was never really the guns themselves. It was the equipment that let other people make guns by the thousand. The heavy boring and rifling machines, and the gauges that kept every barrel and every lock identical. That machinery went into armories at home, and before long into arms factories overseas as well. Decades later, in a 5-volume history of automatic weapons compiled for the United States Navy, Lieutenant Colonel George M. Chin described Francis Pratt as one of the finest machine tool designers there was. Chin noted that although Pratt had founded the company to make guns, the other products turned out to be so profitable that within a generation hardly anyone remembered firearms had been the start of it. The war made the company. It also aimed the company straight at the problem that would define it, because you cannot mass produce a rifle or anything else unless every part is cut to the same exact measurement every time.
The young firm nearly did not live through its first decade. In 1862, a fire destroyed the shop. Plenty of men would have taken that as a sign and gone back to steady employment. Pratt and Whitney rebuilt instead. They brought in a third man, Monroe Stannard, as a partner to help get the operation back on its feet, and the rebuilt business took the name it would keep from then on, the Pratt and Whitney Company. By 1864, it had grown enough that the two founders finally left their jobs at the Lincoln Works for good and went to work full-time for themselves. Their side project had taken 4 years to become their living. In 1869, they formally incorporated the company in Connecticut, capitalized at $300,000. That same year, they made 2 hires that say a great deal about the kind of place they were building. They took on a young man named Worcester Warner to design gear-cutting machines and another named Ambrose Swayze to build telescopes. Both men learned their trade at Pratt & Whitney, and in 1880 both left to start their own firm, Warner & Swasey, which became a major name in machine tools and astronomy. The Hartford shop had become a training ground for some of the best mechanical minds in the country, and its 2 owners seemed perfectly content to school the very people who would go out and compete with them. By the 1870s, the company had outgrown any short description. It made guns and gun machinery, lathes, drills, screw machines, die sinkers, wrenches, planters, weighing scales, and the precision tools used to make all of them. If a factory anywhere in the country needed a machine that could hold a tight tolerance, Pratt & Whitney was one of a small handful of names worth calling. The firm shipped its machine tools and gun-making equipment to armories and factories well beyond Hartford and well beyond the borders of the United States. A later company booklet claimed, with some justification, that you could write nearly the entire history of the modern gun industry using nothing but photographs of the machines and fixtures that Pratt & Whitney had built and sold to its customers. The machines were only half of the story, though, and the 2 founders understood that better than anyone. A precise machine is worthless if the man running it cannot measure what he has made. A lathe that can cut to 1,000th of an inch means nothing if there is no agreed 1,000th of an inch to cut to. Pratt & Whitney could build the most accurate equipment in America and still not solve the deeper problems sitting underneath the whole industry. Nobody could say, with real authority, exactly how long an inch was. That sounds like a trivial thing. It was anything but. 2 factories building the same part from the same drawing would still turn out parts that did not match, because each was working from its own slightly different reference. One shop's inch ran a hair longer than another's. Multiply that tiny gap across a complicated machine with dozens of parts, and the entire idea of interchangeability collapsed. Parts had to be filed and fitted by hand during assembly, which was slow, costly, and exactly the kind of labor that mass production was supposed to do away with. The bottleneck was no longer the machinery, it was the ruler.
So the two men set out to fix the ruler, not just for their own shop, but for everybody. In 1860, there was no commercial standard of length in the United States worth the name. There was no official American inch, no master yard locked in a vault that a factory could check its tools against, no settled reference for the meter either. Every measuring tool in the country traced back sooner or later to somebody's educated guess. For a nation trying to build sewing machines, bicycles, rifles, locomotives, and 100 other complicated products out of interchangeable parts, that was a foundation made of sand. In 1879, Pratt Whitney set out to replace the sand with stone. They hired two of the sharpest scientific minds they could find and pointed them at the problem of measurement itself. The first was William A. Rogers, a Harvard professor and astronomer who knew about as much about precise measurement as anyone in the country. The second was George M. Bond, a young graduate of the Stevens Institute of Technology who would go on to head the company's gauge division. Their job was not to design a faster lathe. It was to define, physically and exactly, what an inch actually was, and then to build a machine that could reproduce that inch reliably enough to use on a factory floor. The work took years, and it was painstaking in a way that is hard to picture today. Around 1880, under Rogers and Bond, the company produced a set of master measuring bars accurate to within millionths of an inch. They made working master copies of the standard yard in both its American and British forms, and a copy of the French meter of the archives, so that an American factory could finally tie its own measurements to the same references the rest of the world relied on. They were assembling, in effect, a chain of custody for length, running all the way from the great national standards down to a tool a working machinist could hold in his hand. Until then, gauges had been almost personal objects. They wore down with use, they varied from shop to shop, and there was no higher authority to settle the matter when two of them disagreed. Rogers and Bond were building that higher authority, a single physical reference that every other measurement could finally answer to.
In 1882, that effort produced its centerpiece, an instrument that became known as the Rogers-Bond Comparator. It could compare two lengths and detect a difference as small as 1/50,000th of an inch, a gap far thinner than a human hair. The machine mattered so much to the history of American measurement that it eventually went to the Smithsonian in Washington, where it remains. For the first time, an American company could take a length, certify it against a true standard, and reproduce it on demand. The inch had finally been pinned down. If you are still with me at this point, that means a lot. A quick like and a subscribe really do help these stories reach more people. Now back to what Pratt and Whitney did with that breakthrough. 3 years later, in 1885, the company turned that breakthrough into something it could sell. It introduced the Pratt and Whitney Standard Measuring Machine, an instrument that let a factory measure with a precision that had simply not been available before at any price. In the years that followed, the company pushed that accuracy even further, down to a few millionths of an inch. And the gauges that came out of its gauge division spread into tool rooms, armories, and factories across the country and overseas. When two separate plants both owned Pratt and Whitney gauges, they were at last measuring against the same inch. A part made in one could be trusted to fit a machine built in the other. It helps to understand how that actually worked on the floor. A factory did not hand every machinist a delicate scientific instrument. It kept a master gauge, traceable back to the true standard, and from that master, it made working gauges, simple hardened steel tools that a worker used to check a part in seconds. A go gauge had to slide on. A no-go gauge had to stay off. If both conditions were met, the part was within tolerance and would fit. Once the master gauges across an entire industry all trace back to the same certified inch, a manufacturer in one state could make a component that fit a machine assembled in another with no skilled fitter required to file it true. That is the whole game of mass production, and it rested on the gouges. This is what the two machinists actually did.
The idea of interchangeable parts was not theirs, and they never pretended it was. Eli Whitney had famously shown muskets with swappable parts to Congress back in 1801. Samuel Colt had chased the same goal on the floor of the very armory where Pratt and Whitney first met. The concept had been argued over for the better part of a century. What no one had managed was to make it work, dependably, in quantity, in the real world. As one account of the era summed it up, men like Eli Whitney and Samuel Colt had talked about interchangeability, but it fell to Amos Whitney and Francis Pratt to make the idea practical on a large scale. They did it by giving industry two things at the same moment: machines accurate enough to cut identical parts, and gouges precise enough to prove the parts were identical. By 1893, the inch they had fought to define had been formally tied to the metric standard and recognized internationally. The reference an American factory checked its tools against was no longer a local habit or a foreman's guess. It was a fixed, shareable, scientific quantity, and a large share of the credit for making it usable on the shop floor belonged to a company started by two men who had begun their careers cutting revolver parts for Samuel Colt.
The consequence was enormous. Once every factory could measure against the same inch, a manufacturer could make 1,000 parts in one building, ship them anywhere, and trust they would assemble into a working machine without a skilled hand standing by with a file. The moving assembly line that would later define American industry was built directly on top of this. You cannot run a moving line if the parts coming down it do not fit. The automobile plants, the rifle factories of two world wars, the makers of appliances and engines and aircraft, all of them stood on a foundation of standardized measurement, and a great deal of that foundation had been poured in Hartford, Connecticut by Pratt and Whitney. For all the precision of their machines, the thing people who knew them marveled at most was the partnership itself. Two business partners who could work side by side for decades without the relationship turning poisonous were not common then, and they are not common now. Pratt and Whitney managed it for the better part of 50 years. One history of the company put it plainly, that rarely had the business world seen such harmony between two associates, a relationship built on mutual trust and a shared, almost stubborn devotion to the same standard of quality. Pratt handled the design and the obsession with accuracy. Whitney handled the people, the production, and the books. Each trusted the other to do the half he did best, and neither seems to have tried to take the other's half. Both men collected the honors that came with that kind of success. They were active in the engineering and civic life of Hartford, and Pratt in particular put his name on a string of patents, including a metal planing machine, a gear cutter, and a milling machine of his own. Whitney lived long enough to see the firm become a permanent fixture of American industry, the sort of company whose gauges were simply assumed, everywhere, to be correct. By the closing decades of the 19th century, the two men who had once cut other people's parts for wages were setting the measurement terms that other manufacturers had to meet. The company eventually outgrew their direct control. In 1901, Pratt & Whitney was bought by the Niles-Bement-Pond Company, a larger machine tool combine, which kept the Pratt & Whitney name and the precision work alive. Francis Pratt did not live much longer. He died in Hartford in 1902 at the age of 74, having spent his final years watching the firm pass into other hands. Amos Whitney carried on for almost 2 more decades. He died in 1920 at the age of 87 while spending the season in Maine, the state where he had been born and had first learned to cut metal. By the time he was gone, the standardized measurement the company had fought to establish was so thoroughly embedded in American manufacturing that scarcely anyone stopped to think about where it had come from. The measuring side of the business did not fade with its founders. It went on producing some of the most accurate instruments in the world. In 1921, it introduced a tool called the supermicrometer, accurate enough to read down to 100,000th of an inch. In 1939, needing room to grow, the operation moved to a sprawling new complex in West Hartford, and over the following years, its instruments could measure to within a few millionths of an inch.
By the early 1960s, the company was building numerically controlled measuring systems that pushed accuracy further still. The measurement business the two machinists started is, in fact, still alive today, now based in Bloomfield, Connecticut, still making the high-precision gauging instruments that descend in a straight line from the work Rogers and Bond did in the 1880s. There is no museum crowd around a gauge block. The men who rely on that kind of precision rarely know whose hands first made it possible. The instruments only grew more accurate over the century that followed, and the work begun by Rogers and Bond outlasted both founders by generations. That is usually how this kind of work goes. The man who invents a flashy product gets remembered. The men who fix the ruler that everyone else builds on tend to vanish into the background of the thing they made possible. Pratt and Whitney never gave the world a single famous gadget you could hold up and point to. They gave it the agreement underneath all the gadgets, the shared inch that let the parts fit. And then something strange happened to their name, something neither of them lived to see.
In the spring of 1925, an aviation engineer named Frederick B. Rentschler arrived in Hartford with a big idea and almost no money. He was 37 years old. He had just walked away from a senior post at Wright Aeronautical after falling out with the financiers who controlled the place, and he was certain he could build a light, air-cooled aircraft engine better than anything the Navy was then flying. What he needed was capital, a place to work, and a name that carried weight. The old machine tool company handed him all three. The Pratt and Whitney machine tool operation, by then part of a larger combine, had idle factory space and a reputation for precision that any engine builder would have envied. It agreed to back Rentschler with as much as $1.5 million, the use of its plant, and the right to put the Pratt and Whitney name on his new venture. On July 22, 1925, Pratt & Whitney Aircraft was incorporated. Rentschler brought in a gifted young engineer named George Meade to lead the design work, and the team set to work in the same Hartford where the two founders had made their name. On Christmas Eve of 1925, the first engine ran. It was a 9-cylinder, air-cooled radial that produced about 425 horsepower while weighing only around 650 pounds, which was very light for an engine of that power at the time. Rentschler's wife, Fay, listening to its hard buzzing note, suggested they name it the Wasp. Within a year, the Navy had ordered 200 Wasp and Hornet engines. That single order launched what became one of the most important aircraft engine companies in the world. A few years later, Rentschler folded the engine maker into a giant new aviation combine, United Aircraft and Transport, and carried the Pratt & Whitney name with him into the corporation that would eventually become United Technologies and later a part of RTX. So the name on the jet engine pushing an airliner down a runway today traces back through a borrowed loan and a borrowed reputation to two 19th century machinists who never built an aircraft engine in their lives. Francis Pratt and Amos Whitney made gun tools, lathes, and gauges. The version of their name that millions of people now recognize was created by an entirely different man, using their reputation as collateral. They had built the precision and the trust. Rentschler borrowed both and bolted wings to them. Strip away the jet engines and the war contracts and the famous logo, and what the two original men actually left behind is something far more ordinary and far more important than any of it. Every time a part made in one factory drops cleanly into a machine assembled in another, thousands of miles away, that is their inheritance at work. The agreement that an inch is the same inch everywhere, certified, repeatable, and checkable against a master, is the invisible thing the entire industrial world still rests on. And Pratt & Whitney did more than almost anyone to make that agreement real and usable on a factory floor. Their machines still surface in old tool rooms, still holding the tolerances they were built to hold more than a century ago. Their gauges set the example the whole gauge industry grew up around. The Rogers-Bond Comparator still sits in the Smithsonian, a monument to the moment an American company nailed down the inch. And the company name, in its aviation form,
is in service right now on engines flying somewhere over your head as you watch this. Most of that legacy is invisible, which is exactly the point. A standard that works disappears into the background. People do not admire the inch when their parts fit. They notice it only when they do not. Two boys from New England, both raised on metal, met on the floor of a gun factory and decided the country needed a fixed standard to build on. They were right. They spent their lives proving it, one gauge and one machine at a time. And the standard they set ran so deep and held so well that it outlived the company they sold, the partnership they treasured, and even the memory of the two men who started it. American industry was built on a great many things. One of the most important of them was the work of Francis Pratt and Amos Whitney. If you made it all the way to the end, thank you for that. If you enjoyed this story, give the video a like and hit subscribe so you do not miss the next one. And if you want more stories exactly like this, click on the two videos you can see on your screen right now. I will see you in the next one.